Thousands of miles from the Gulf of Mexico is the picturesque town of Trondheim, Norway. Here at SINTEF, the Foundation for Scientific and Industrial Research, scientists are collaborating with a team from Johns Hopkins University to develop better ways to ease the impact of future oil spills.
After Deepwater Horizon, I really questioned myself in terms of what did I need to learn in order to be a better responder in the future. So I brought my family here to Norway so that I could gain that expertise and what could I contribute in terms of developing tools and modeling capabilities. The Tower Basin is where we do studies for droplet size, so we can simulate a blowout on a small scale. Our hope is that we can, in real time, be able to monitor and potentially alter the droplet size distribution. And that's important because the droplet size distribution determines how much of the oil stays in the subsurface versus how much reaches the surface.
We learn something new every time we do an experiment. Small droplets are good because they rise slowly. A large droplet will be very buoyant and it'll reach the sea surface quickly. You have a very thick oil slick, which is very difficult in some cases to clean up.
Norwegian scientists are not the only Europeans collaborating on oil spill studies. Less than 1,000 miles to the south, in Germany's second largest city, is the Hamburg University of Technology. Here, scientists, in collaboration with colleagues from the University of South Florida, are also searching for new ways to understand the impact of oil spills. Karen Malone is a master in mechanical engineering. She is focusing on the future, when deep-water spills may become more common as Gulf of Mexico oil exploration goes 2 or 3 miles below the surface.
The experiments we're doing here are pretty unique and pretty new to the world of oil spill science because to date, we mainly had spills on the surface or in very shallow waters. This is deep water. So in our experiments, we're replicating the exact environmental conditions we're having down the Gulf of Mexico.
It's like sitting on the floor of the ocean and watching the droplets and bubbles that are rising under these extreme conditions.
This is the first time we have the possibility to replicate this in a lab and to really find out what is driving these processes.
It's really a miracle that this oil spill brings people together all over the world, independent of the language of the country where they are coming from.
And as new technologies continue to emerge, funding and collaboration between research laboratories becomes much more common.